that way, like neat as in like clean and simple. So the one that I'm bunching into one vessel, I'm calling the vena cava. There is in fact a superior and an inferior. So if you can see, they're really the same thing. One's all the blood coming from below your diaphragm, one's all the blood coming from above. So all the veins that drain right below your collarbone, or actually on top of your collarbone, tons of venous blood is just seeping in here, and then blood is coming up from your liver and from your lower extremities and seeping or being slowly pumped and trickling in to the inferior vena cava. And so I group those together as one because functionally it's the blood that's entering the right atrium, or really entering the heart. It's the first stop, basically. This is the first area that you're going in. So those are those two, thin, relatively thin-walled. So you should know that this is an input vessel, which is low pressure. So is that clear? The other thing that you can do is look into them. And these are big enough you can do this. You can actually start to get a feel for what an atrioventricular valve looks like. It's kind of messy. It's kind of like the ground is caving in, it's big, and there's fibers in there. You can look in that one too.
Yeah.
And that's a very different look than what you'd ever get looking into any of the arteries. Because any of the arterial, the outputs, either the aorta or the pulmonary trunk, they have the semilunar valves, which are these neat little flaps. That's all they are. These are much more complex looking things. So that's another way to confirm that you're in some kind of an input vessel, meaning it's going into the heart. So superior, inferior vena cava. So there's only one other input vessel. And you know that that's it based on looking at the kind of valve. That's an AV valve right there. And we've already established that this is the vena cava. So what is the other one that brings blood into the left ventricle? So you got to be able to pull that off the top of your head. That's what you got to know, and it's fine that you don't now, but that's the kind of, if you know that quickly, then you can just reason your way through all this stuff. You don't have to try to like memorize it like you would a face or something like that and try to get every subtlety. Then you can just reason your way through. So it's really, I encourage you to make sure by the end of today, you can just draw a heart on a piece of paper, draw 4 tubes, 2 going in with arrows and 2 going out, and divide it into a left and right ventricle, and make sure you can name the vena cava, superior and inferior, the pulmonary veins, which are the only other input vessels. These are coming from the lungs to go into the left atrium, then into the left ventricle. And then the only thing that's left is the pulmonary trunk, one of the 2 output vessels, and the aorta. And so you need to be able to pull that out of your memory quickly, and then you can just say, oh, okay, AV valve, this is the right side, this is the left side. If it's an AV valve on the right side, it has to be vena cava. If it's an AV valve on the left side, it has to be pulmonary veins. And so make sure you can map that out first. You may want to pause and just do that and kind of get that down. And then the vessels are really straightforward, because there's really only 4 things. And then you can take a look. I'll point out a couple of the other features in here. That's the bottom of the AV valve. So here's what I described as a tent. So these are really flimsy. This is why you need them to insert on the papillary muscle. So when I open this up, it tightens, right? And so basically these all constrict and pull that AV valve closed so that blood doesn't rush the wrong direction. You can see it up in there too. It's much stronger. See how many more tendons there are? Because again, 10 times more pressure inside of the left ventricle. Right ventricle is puny. It gets up to like 20 millimeters of mercury. This could get up to 200 depending on what you're doing. So you need a much stronger AV valve in here to deal with how much pressure you're going to generate. What else? Connective tissue layers you can see pretty clearly here. They'll even start to peel off. Simple squamous epithelium. And that's that visceral layer of the pericardium, or also called the epicardium. They're the same thing. There's 2 different terms. The one thing this week where there are 2 different terms for the exact same thing. There's also an endocardium, which is the same type of tissue but on the inside. And it's a little harder to peel off on the inside.
Just shiny.
Yep, but it makes it kind of opaque. It covers the inside. The reason for that is you want it to be really smooth, because blood will clot if it encounters a really rough surface. And so this is really smooth, and it's continuous with the arteries and veins. So like if you were a blood cell going through the heart, it would be a smooth, put your arm out and start feeling the sides of the wall, it would be smooth the whole way. You wouldn't notice really when you went from the heart to the out to the aorta. It's a continuous layer of connective tissue the whole way. And then moderator band. You guys actually don't have a really, really clear one. The function in your textbook kind of emphasizes there is a piece of something in there.
What is that? A styrofoam.
So that's the Corday styrofoam. That's what you develop. I have no idea. It's probably just when it was packaged.
Oh.
I don't know.
That's hilarious. There's something in there.
Something in there that you don't need to know about. But the moderator band probably came off right here, and it's this band of myocardium that goes from the interventricular septum, which is the dividing the wall between the left and right ventricles. It goes from there all the way into the far wall of the right ventricle. It was thought that it moderated the tension on the wall, like had extra support when the right ventricle expanded. That's why it got its name. It's since been learned that it's part of the conduction system, and it's really mostly important for having the depolarization jump to the right side of the ventricle more efficiently. So, but it retains the name moderator band, and it's a distinguishing feature of the right ventricle, in addition to the fact that these walls are super thin compared to those. And it really is as simple as that. You'll always be able to see the wall thickness. So that's pretty much it. Papillary muscles, yeah, all sorts of fun stuff. Coronary blood flow coming through here into the right coronary artery, left coronary artery here. The sulcus is just the crack. And so the artery's, I believe, still in there, but it's sitting in the sulcus. So that's just a little groove in here. And that's another thing that can kind of orient yourself. And so these are actually pretty like models.
Yeah.
You know, they look very, very similar to what you would see in a picture. And so yeah, as long as you can get that map of the blood flow in your head, and you're going to need to answer questions like that on our practical or on our exam too. Like you should be able to come up real quickly with what's the vessel that brings blood to the heart from the lower extremities, that kind of thing. We have a blood vessel week in 2 weeks too, where you'll have a chance to hit those again. But make sure you can do that, and that'll really help you. And then, oh yeah, the atrium is up here. It has the auricle of the atrium, referring to its ear-like appearance. Like there's a little ear, and so it's really just this flap right here that hangs over. And so if anything's indicated there, like just in this flap, probably from my thumb forward, that's this auricle, this ear-like appendage that hangs off the front of the atrium. And when it inflates, these things, if you see it really pop, they really get big. They blow up real fast. And this is where the extra slack is, sort of, so that these can expand. So the auricle disappears when they're totally full. They get stretched out. And here's another one back here.
Here.
And yeah, that's pretty much it. So get the map of blood down, and then you'll have that down perfectly.
Thank you.